Learners, greetings. In the previous four sessions, basically, I told you what is mean, what is median, what is mode, how to calculate mean, how to calculate median, and how to calculate mode. And definitely, we have taken so many examples so that you may know how to calculate mean, median, and mode, which comes under the category of measures of central tendency. Now, one question arises and it is frequently asked that what's the relationship between mean, median and mode, how they are related with each other. So in today's session, we are going to cover this topic. So how they are correlated with each other? See, uh, it is very much evident that mean, median and mode are three measures of certain tendency that has been already explained to you. They help to find the central value of a data set, already it has been discussed, and the relationship shows the nature of data distribution. So what does it mean? The nature of data distribution. There is one empirical relationship that exists between you can say mean, median and mode that can be expressed by this formula: mode is equal to 3 median minus 2 mean. So it is approximation, or sometimes we say it crude value also. So what does it mean? I mean, after studying so many distributions, finally we have approximated certain kind of relationship among mean, median and mode, that if we know the mean of that particular distribution and if we know the median of that particular distribution, then we can somehow predict what will be the mode by this formula. Multiply the median by 3, multiply mean by 2 and subtract whatever you get after multiplying by mean from the that you have got by multiplying 3 to the median, and by that way you will get the mode. Let's take one example and then definitely we will be able to understand. First case I have taken symmetrical distribution, and symmetrical distribution in the previous slide I have discussed that NPC, that normal distribution in which exactly the whole curve is divided into two parts by the mean, and 50% score lie towards right hand side and 50% score lie towards the left hand side. And in this case, mean, median and mode, they lie on the same point and they are equal. But this happens only when the distribution is perfectly normal. So what happens in positively skewed distribution? So tail is toward the right. So what is tail? Let me draw it again. This one. So mean is somewhere here. Tail is towards the right hand side, and tail is towards the right hand side shows more scores here, less scores, and this will not be a symmetrical curve. That is, mean will not divide exactly into two parts. One part will be greater and another part will be smaller. In such type of situation, always remember that mean will be greater than the median and median will be greater than mode. That is, mean will be biggest value and mode will be the smallest value, and median will lie between mean and mode. Let me explain. I am discussing a situation, a distribution which is positively skewed, meaning by more scores are there in the curve towards the right hand side. In that situation, the moment you will calculate mean, median and mode, you will find that mean value comes out to be bigger in comparison to median and mode will be having the smallest value, whereas median will lie in between mean and mode. There is an example. Suppose you are taking a data on income of the people. So the moment you will take income of the people, so what will happen? I mean, it will never happen that everybody is having the same type of income. Few people will have high income, few people will have definitely low income. So in that situation, you will never get a symmetrical distribution, rather you will get a skewed distribution. Let's proceed ahead and see what is the situation in negatively skewed distribution. So remember, in the negatively skewed distribution, tail is toward the left. So what does it mean? Let me write something like that. Something like that. Tail is toward the left means more score are here and less score are here. That is a distribution in which most of the scores are less than the mean value. So what will happen in this situation? See, mean will be less than median and median will be less than mode. So what will be the relationship? By that way, you can say mode value will be the highest and mean value will be the lower one, whereas median will lie between mean and mode, in the same way as in the previous case where we have found that median lies between mean and mode. So in positively skewed case, as I explained, mean will be greater than median and median will be greater than mode, but in negatively skewed distribution, situation will be completely different. Mean will be lesser than the median and median will be lesser than the mode, that is mode will be the highest value. Now let's take some examples and let's do some calculation. So I have taken one example in which mean is given as 40, median is given as 35 and you are supposed to calculate mode. So what to do? Mode, remember the formula, mode is equal to 3 median minus 2 mean. So in this case, median has been given as 35. So 3 into 35 minus 2 into 40, because mean has given here 40. So simplify. So 3 into 35, that is 105 minus 2 into 40, that is 80. So finally mode has come out to be 25. Again remember that this is certain kind of crude value. This is certain kind of approximation, and this approximation has been done on the basis of the nature of the distribution of the data. So let me take another example. Suppose there is a situation in which you have got mean as 50, median as 48. Now you are required to calculate mode. What will be mode? Again use the same formula. Mode is equal to 3 median minus 2 mean. So mode is equal to 3 into, what is the median? You see, it is 48 minus 2 into 50. Simplify, it is 3 8s are 24, 3 4s are 12 and 144 minus 100. So finally it is 44. So in this situation, when median and mean are given and you are required to find out the mode, you can easily do it by this type of approximation. Let me take another example so that it might be clear to you. So this time I'm going to take another example. Suppose there is a distribution for which the mean has come out to be 75, whereas the median has come out to be 72, and you are required to find out mode. So use the same formula. What you will do? Mode is equal to this formula, 3 into median minus 2 into mean. So 3 into 75 minus 2 into 72. Simplify it. So it will be 225. It will be 144. So subtract and get the answer. So it is 1, it is 8. So by crude approximation, we have got mode as 81. So basically, this is a very good formula or a very good approximation through which, by knowing just mean and median, you can easily calculate mode. Now, let's study this symmetry table. Already it has been explained. Remember, if the distribution is normal, that is, distribution is following NPC, normal probability curve, this is the best case when mean, median and mode are equal. But in practical life, in real life, this hardly happens. I mean, hardly we get any distribution which is perfectly symmetrical, because a certain kind of skewedness is there, that is, more score lie towards the left hand side of the curve or more score lie towards the right hand side of the curve. So in the symmetrical case, mean, median, mode, remember, will lie on the same point and they will be equal. Now let's take the case of positively skewed distribution. So in the positively skewed distribution, mean is greater than the median and median is greater than the mode. So median will lie between mean and mode. Whereas in the negatively skewed case, again, mean will be less than median and median will be less than mode. In both the situation, you will see that in these both situation, basically median lies between mean and mode. So through this table we can easily understand. Another beauty of this table is that by simply seeing the value, suppose there is one distribution whose mean is 79, median you can say is 74, and mode is suppose 70. Now see the values. I am repeating, mean is 79, median is 74 and mode is 72. Now you have to judge whether this distribution is a normal distribution or positively skewed or negatively skewed. So through these values you can check. How? Since all the three values are different, that is, mean is 79, mode is 74, median is 74 and mode is 72. So definitely it can't be a normal distribution. Now see, mean is having the higher value than the median and median is having the higher value than the mode. So come to the second situation. Second situation in this table says that if mean is greater than the median and median is greater than the mode, so by that way you will say that distribution is positively skewed. So if you are asked, you are simply given the values of mean, median and mode, and you have to judge or you have to assess that whether that distribution is skewed positively or negatively, you can take a decision and you can easily say that in that situation that distribution will be positively skewed. Let me take another example. Suppose this is the case, mean is equal to 70, median is equal to 71 and mode is equal to 72. Let me repeat, there is a distribution for which mean has come out to be 70, median has come out to be 71 and mode has come out to be 72. Now you are required to judge whether this is a positively skewed distribution or negatively skewed distribution. Very easily you can take a decision. See, in this case, mean is less than median and median is less than mode. So definitely you can take a decision and you can say that this is a negatively skewed distribution. So in a nutshell, remember this table. Let me summarize it. For the perfectly symmetrical distribution, mean, median and mode will be equal. For the positively skewed distribution, mean will be greater than the median and median will be greater than the mode. But for the negatively skewed distribution, mean will be less than the median and median will be less than the mode. Conclusion. What we have learned during these 20-25 minutes. This relationship that we have studied that exists among mean, median and mode, that is mode is equal to 3 median minus 2 mean. This relationship helps to identify the data skewness. It is something very advantageous to us. Sometimes when you are conducting research, or sometimes you might write a research paper, and for that you have taken some data and you have to take a decision whether data is normal or skewed or like that. So simply by calculating mean, median and mode, you can come to some conclusion whether your data is skewed or normal or positively skewed or negatively skewed, like that. So this relationship helps you in that situation. This is very useful particularly in statistics, economics and education. And you see, economists, they calculate the national income or the average income, or sometimes lower income group or higher income group or something like that, or sometimes they calculate the wages, sometimes they calculate the salary. I mean such type of things. So in that situation, it will be very easy for them that population that has been taken by us is a normal, following a normal distribution, or it is positively skewed or negatively skewed. And finally, it is a strong tool to understand the data patterns. The same thing that in the beginning I explained, data patterns, simply which distribution the data is following. So for further studies, I have written these books. All the three books are very good. First book, Garrett, you can see the reference, Guilford book, and third book, it is written on the slide. Go through all these three books if you want to know further more about this relationship that exists among mean, median and mode. For today's session, it's enough. We will come with some other topic. Thank you very much for listening to me.